Good afternoon. Is everybody awake still? Did you get your lunch break? Did you get some coffee? Some soda? I saw snacks out there. Excellent. Did everybody get their gifts from their early Christmas gifts from Steve, Uncle Steve, we like to call him? Pretty cool. I still don't have one of the new Windows Phone 8, so I'm pretty jealous of you guys. Actually, we were just commenting. We were wondering if we can jump behind the counter and grab some of the swag, but
yeah, I tried, but they told me no.
They told you no. So my name is Chris Anderson. I'm a development manager on the developer experience team inside of Windows. For Windows 8, I was working on the Windows JavaScript library, but in a past life, I spent a bunch of time working on WPF, and now I'm actually helping to run the team that produces XAML in addition to WinJS. And so I'm here to hopefully go through kind of the basics of XAML and talk about how the platform fits together and go through that. And as always is my ample companion.
Trusty sidekick.
Trusty sidekick.
My name is B. Jordan. I was the XAML graphics lead for Windows 8 XAML, and before that I worked on WPF and Silverlight. So I've gone through the entire spectrum of XAML-based development platforms in my career at Microsoft.
Excellent.
So this is the best one yet.
Everyone is the best one yet, isn't it? I think
true.
XAML is probably the platform we have put in the most locations of any of our UI technologies.
That's true. We love the XAML.
I think we just got to get it on the Spot Watch.
Yes.
Like if
we still have that.
no one remembers the Spot Watch.
Yeah,
So
I was going to say.
All right. So first, the question that we generally get is kind of, how should I build my apps, and why do we have all these different UI technologies? You know, in Windows 8, there's kind of three primary ways of building UI. There is DX, basically target directly to C++ and use DX and run on the graphics hardware. There's the XAML stack, which allows you to use any language you want, C#, C++, or Visual Basic. And then there's HTML and JavaScript. People often go, well, why do I use one? And probably the biggest thing is really the call out here, which is build native apps using the technology you already know. The highest order bit in terms of when you go to build something, is the thing that's going to make you most productive. The XAML stack we have, it is an evolution of what started in WPF, what has become Silverlight, and the phone stack. And so it's very familiar if you've used any of those XAML stacks. Like I said, you can use any language. And in this version, what we've done is really built the XAML stack from the ground up in native code. So the entire thing is built directly on top of DirectX. And just to kind of show this, I want to quickly go in and show a little bit of the interesting things of what you can do with this. So go to 3. So previously, you were limited to managed code to target XAML in WPF and Silverlight. What we've done here is like I said, it's all C++ code. And here we have a little tiny project. Can you open up the CPP file?
Yep.
And if we scroll down, there's actually no XAML here. It's a XAML platform that we're showing off a demo with no XAML code. This is C++ code talking directly to the object model. And in fact, if we step in, if you F11, please, we'll see the first thing that gets hit is WinMain. When's the last time you guys all saw WinMain in your program? Even with all the new Windows 8 features, it still looks the same as your classic Petzold programming, but we can go in here and run. We hit our app start, we step into this, and you really see that it's just a bunch of call stacks in your native code, so you can program in at any level of the stack. Great. Makes sense? Hey, we got a button. Can I click? Does it do anything? Hey, look at that. Awesome. So let's talk a little bit about the architecture of the platform. So one of the things you'll look at the bottom here is the set of Windows subsystems: media, app, theming, PVL, direct write. One of the things, if you look back historically at WPF, the stack was this large vertical of lots of different pieces. That we had a rendering layer, we had a text layer, we had all these pieces together. And over time, what has happened is we've taken those bottom pieces and actually integrated them into the core OS and kind of segmented them out into these reusable libraries. And so you see things like Direct Write and Direct 2D, which are evolutions of what used to be present only in the XAML stack. And in this version, we've really taken the last step and taken the whole rest of the stack and converted it over to C++. On top of that, we built a graphic engine, which is kind of familiar with like Milcore, I think was, didn't you say we renamed it?
WPF GFX.
WPF GFX. is this low-level graphics engine, and then we have kind of the core and framework, which are what people think of as XAML in general.
Programming model, yeah.
The last interesting layer here is this thing at the top, which is the XAML ABI support. And what this is, it's the programming model, the facade we put on top of that runtime, that is a native code layer that then gets projected into WinRT libraries. So WinRT is a language agnostic runtime, and so on top of that we can build C++, C#, and VB code. So that's the basic architecture. There's another interesting thing that in terms of that's useful to understand. You know, one of the big reasons why people like XAML is the fact that it allows you to get down to the guts. You can program it to DX. You can really target the core platform. You can write it in native code. But people like to understand that they can go in and tweak the individual performance of how this app is running and really eke out the last cycles of the processor. And so it's useful to look at kind of the general threading model, which is unlike Silverlight, for example, which was really a single-threaded model. In XAML on Windows 8, we've really split this apart. We have a couple of threads here. And the main one is that we have this UI thread, which is where all of your code runs. From the perspective of this audience, that's all we care about. It's the UI thread. Everything runs there. Events get dispatched there. Your code always runs there. But in the background, there's this compositor thread, which is really where Bead lives. And so Bead is the only one who's allowed to program on that thread. And this is where independent animations go. This is where we take all of that XAML and actually create pixels on the screen. But it doesn't happen on your UI thread. So we're able to take advantage of multi-core machines. We're able to have independent animation. And most interestingly, we're able to have independent input. So you've all been playing with your surfaces, I hope. And you've been noticing that, well, hopefully been noticing, that as you move things, the content sticks to your finger as you move it. Well, that finger's coming in at 100 hertz. And we need to move all the graphics underneath there at the same speed so that it appears to be right underneath your finger. And for that, we actually run a bunch of those animations, a bunch of that movement on this compositor thread. So without your application being involved, if you use the XAML scroll viewer and you touch down in it and you swipe and slide, that content moves without your application even being notified because it's inside of one of these platform components that understand how to talk to this compositor thread. Do you have anything to add?
Zooming works too.
Zooming works, etc. Yes.
Also, you can also still create your own background threads and do your own extra work on.
Oh, of course.
There, yeah.
Yes.
So,
create thread is your friend.
Yes.
And we all know that more threads is better.
Always better.
Yes.
So I have the extra box, multiple worker threads for image decoding. Just keep those around.
Great. Awesome. So I wanted to kind of talk a little bit about the grounding of XAML and how it's different than the XAML you may have known, which is really why I wanted to dive into kind of some of those the icky details. But this is really the XAML that you know and love. The XML markup, the fact that you can do these little angle brackets, the fact that you can go and use all of these controls that you're familiar with, and this is kind of where we're going to spend most of the rest of our time. There have been a few changes to this XAML markup. Some of the type definition features have been pulled out. So if you're familiar with like X subclass or some of those other features, those are gone. And the type system moved to WinRT. But otherwise, you can pretty much take XAML that you've seen before and use it again. Bindings present. You can do resource lookups. You can do styles with that. Animations are there. All of those features that you're familiar with are built in still. A couple things are missing, like notably type converters aren't there in Windows 8. And so there's a few little details. But in general, if you did it before, you can do it again. And so just walk through this. Let's drop in and switch over and do a little code. So we'll start by creating an empty project. The language of your choice. C#, not COBOL.
When I was younger, yeah. But not so much anymore.
Great. So let's go into the XAML and we'll just write some code here.
Okay. Great.
So you'll notice the namespaces are familiar. The XML namespace, apparently we stopped innovating in XML namespaces in 2006. We made it constant, so we'll go in here, create a button, put some content inside of there. A button. Some other fun tags that you'd like to do. Great. Ooh. Window creativity, what color?
Goldenrod.
Sweet.
It's a nice name.
All right. One more. Let's. Should we fill in that event handler?
Checkbox.
Oh, combo box too. We have all the controls you need. Combo box and button. All right, so we go in here to code behind. So in this case, we're using C#, so we're able to go use all of our normal C# features we expect to find. So we can go in here. You need to import that namespace really quickly. Everything in, or most of the things in WinRT are asynchronous. And so here we're going to call m.showAsync, which is going to be our thing that kicks off the dialog. And that actually has a async result. You can use the await keyword and chain a bunch of these things together. In this case, we really don't care what the result is, and so we're going to run. Excellent. That is exciting and thrilling.
It is. Much faster than C++ as well.
Must. Are you saying that? Great. Awesome. Is there more of XAML that you'd like to show off? Or should we move on and extend the platform?
Let's extend the platform.
Great. One of the things I love most about the XAML platform that it really is a differentiated value that you can go and leverage here is the fact that the XAML platform is built out of the same building blocks that you can write your code against as well. So what we're going to do here is we're going to create a custom control. Oh, wait. We're going a little out of order. That's fine.
Oh, okay.
No, we're good. We're good. We're going to keep going.
Keep going.
Walk through the pain. So you picked the wrong language.
I picked the wrong language.
Oh
terrible.
my goodness.
I know.
All right, we're gonna.
Or express my preference for C#. So.
So in XAML, the platform is built out of all these C++ classes. What you can do is you can actually extend the set of nouns that you can use. You can create new controls, and you create those new controls using any language you like. The power of this means that you can create a reusable control that is in C++ just like we wrote the platform in, and now your consumer, the apps that are built on top of you, can be built in any language as well. So they can use the WinRT and they can be written in C#, VB, or C++. And this really gives you... oh, you switched back? Sorry. I apologize. Deep breath.
More code or more
No. We're going for this. One of the things that we've heard feedback from as people have built apps, we've had the Windows 8 has been out in the store or been out available for people for about a year, and we've had a bunch of apps being built. There's several thousand apps in the store, and we've had a bunch of experience where people have started building classes using XAML, using HTML, using all of these and shipping them. And one of the things that we've seen is that the language you choose to implement some of these reusable libraries can have an impact on the app that's using you. So for example, if you're a controlled development company, like, I don't know, Telerik, or if you're a Component One, then really building these in C++ allows you to create new extensions of the platform that can be used without making your customer pick up the GC or any other policies. Now, if you're building an app for yourself and you want to have some controls in it and you want to reuse them, C# and VB is a great way to build these libraries, and it's definitely far more productive, if you're familiar with C#.
Yes.
So now
I hate to admit it, the C# and XAML is much faster than just writing C++.
It is. So great. Now let's go back and let's show how to do a C++ class. Great. So we recovered from our little faux pas there. We have our class. We've built our control. Let's delete the C++ that's there. And we're going to do is we're going to create a custom control in C++. So right-click and do add a new item. And we're going to add a new templated control. And templated controls are kind of the building blocks. These are the reusable controls that can have custom styles applied to them. Great. So let's go in and look at the CPP file. There's a bunch of using namespaces, and we have a control declaration. So there's no magic here. It's a pretty simple file. In fact, even I, who rarely code in C++, can look at that and go, yeah, I get that. Here's the definition of the type. We're going to switch its base type to be content control, because we want to have just an internal single property that has the content. And then the last thing we are going to do is define a style for this. So you see, even in C++, we can go in here and use the XAML. We can define our default style sheet for it. Let's just put a content presenter inside the border. And then we'll build. And the same process can be done for any of the language that we have. We just needed to build. We didn't need to run. Great. And now let's go to our app and add a reference to it. Excellent. So now we've added a reference from our C# project that we were just looking at into our C++ file, which has our default style sheet defined, it has our control defined. And now we're going to go in and add a namespace declaration, which we're going to do using. And this is one of those changes from the WPF, or the XAML that you've seen before. We're using for this. We're going to reference our class that we had. And then to our stack panel, we'll just add a reference to our class, which is MCC : custom control. We see we get statement completion and IntelliSense across the boundary. We'll put some content in here. Let's make the content be hello world. And then again. And then F5.
Wheels are turning.
Great. That's very tiny
It's
text.
very small. I'll make it bigger.
But it's there.
Yeah. Can actually go style it real quick.
So resources are a way of defining a set of reusable objects that are going to be applied to the elements. In this case, we're going to style and we're going to target type that custom control that we just wrote. And we're going to say that all we want to do is we want to set a property, which is called font size,
Yep.
let's say. And give it a value of 30 point, 30, great. And then we'll run. Excellent. So that's simple C++ control being referenced from XAML, styled. It all plugs together. And really this is, again, like I said, one of those things that you can do that is kind of uniquely XAML, of being able to extend those downs in the platform. Fabulous. All right. So we're touching on some of the differences of the XAML you have today and the XAML you've known in other platforms. One of the big things that, as we did touch, we were talking before about that responsiveness and how to have the input running at good speed. And we said one of the big challenges we had was with Windows 8 was to develop a platform that would work great for mouse, touch, and pen and keyboard. So we've gone and unified all of the kind of pointer inputs. Touch, pen, mouse, all route through the same event, which is a set of pointer events. So as opposed to having a mouse event and a pen event, we just have one. What this means is that you may have multiple points of input. So unlike previous platforms where there's only one mouse, we now have a model where you could theoretically plug in like 40 or 50 mice and have all your friends grab their mice at the same time. Or more likely, more fingers. The other thing that's interesting about this is that the input for these varies widely on the performance. So mice come in at a certain speed, touch comes in at a much higher frequency as we try to get the low latency, and pen's even faster still. And so there's cases where you actually get more data than you can process as you go. So we'll go through and show a demo for that in just a second. But the other point is keyboard. So we love keyboards. Keyboards are nice. You guys all got one. It works out well. You snap it in. It's good. But what you want is we want to have this also work with touch keyboard. And we also want it to work with IME. We want it to work with accessibility. All of the features you expect from a modern platform. And so really the bullet point here is use the built-in controls. Use the built-in text box for your text input. If you need to handle key input, that's fine. But it all gets routed through the same event, which is the one you've known in the past. But the real message is use text box. It's your friend. You want to get the selection for free. You want to get all of those things.
You're going to get the soft keyboard for free.
So let's go in and use the new pointer event, which is really the thing that is new in XAML, kind of the thing that's unique here. So let's go in and create a new XAML project. We're going to write some code here. So we're going to go in and we don't need this silly initialize component because we're not going to do anything in the XAML. So let's create all code. Excellent. Let's go create a memory variable called canvas1. That's a canvas. So we're just going to paint into this. We're going to create a little multi-touch paint. We're going to show you how you can have all of your fingers work. We'll say canvas equals new canvas. And then we'll also set that to be the content of our window. Of our page, sorry. Set the background to be something interesting. Great. Not yet. You do not have the all-knowing keyboard yet, or the IntelliSense.
I think I just typed it wrong. It's my fault.
I'll blame you. The color interpretation.
Yep.
Colors. Great. Awesome. This app is exciting so far. It's definitely more visually appealing than the last one. It's more unique.
It's got my favorite color.
We can sell it for more in the store. All right, so now let's go add some event handlers. We'll add the pointer pressed, pointer released, and pointer moved. So the key thing here is that as the contact points touch down, we need to keep track of all of them. And so we're going to listen to the event so that we can know when one finger goes down so we can paint on both fingers. And then we'll do the pointer move. So because we need to keep track of these pointers and need to keep track of all of the fingers, we need to have a place to store the information. So could you create a dictionary up at top that goes from uint to color? Because we're going to paint each finger with a different color. Oh, you don't like to do member variable initialization in line, do you?
No, I don't. I'm afraid of it as a C++ developer.
I like your combination. You're very conflicted of knowing when you want to use C++ and C#. It's awesome.
Internal battle.
So on pointer pressed, we want to go capture the pointer. So let's go down here, and instead of throwing and crashing, we're going to go and say canvas1 dot set capture or capture point, and we'll grab the eat up pointer, which gets the pointer. So we're going to get, as each finger goes down, they're going to press, and we're going to grab that pointer so we keep track of it. We're going to go store it in our map. Great, so we probably want to create some, that map is from uint to color. So we want to allocate a color for each pen, for each thing, right?
Yes. Okay.
So we're going to go in and generate some random color, please. Colors are consisting of 3 points, 3 colors, R, G, and B value. We'll just go use a new random and go fill that in. R dot next bytes. Great. Keep going. Excellent. Byte sub 0, byte sub 1, byte sub 2. Great. And you need to fill those that byte array in, or else they will all be 0. It will be the most uninteresting program we have ever done. Great. So we've got our points, we've got our color, we'll go sign that in, and we're good to go. So now we've captured the point, we've allocated a color. We now want to say when we release the point, of course we want to release capture. So we'll say canvas1.release pointer capture. And then we'll just delete the pointer from the list. So now we've done our bookkeeping. So we've, on the pointer down, we've captured the point. On the pointer up, we've released it. We now have all of our, we're ready to party. And now let's go and fill in the pointer moved. Now for all of our sanity, Beat has
I can't type that fast.
Carefully
prepared one of these earlier today.
This is great. So let's walk through this code really quick, just kind of explain it. So the first thing we do here is we grab the pointer, the color that we want to use out of that map, right? So we've got all these fingers down, we want to figure out what color we want to use. And then we need to go and look at the intermediate points. So you remember I said that some input comes in much, much faster than others. So in this case, we only get a pointer moved on an occasional basis. When that UI thread gets activated, we're ready to run on that. And so the pointer may have moved a bunch in between there. So as opposed to having a really chunky line, we're going to go look at all the intermediate points from the last time we asked this question, and we're going to get back this big list of them. So we're going to go grab the position, and then we're just going to create an ellipse here of a certain size, and then fill it in. And so I think we should be good to run.
Great to go. Oh no.
Oh, I love it. The audience IntelliSense is working. You don't have a plural on your from ARGB.
Thank you very much. You're all just waiting, were you? Lying in wait.
They were suckering us into it. Like, this is what you get for going in the wrong order. Okay, touch
ready?
it. Touch
ready?
it. Ooh. Oh. Can it do 2 fingers? And now
only 2
pen.
fingers, unfortunately.
And you'll notice the pen, well, I guess this one, you moved your finger slowly before, but you see that there's a lot of intermediate points on the pen. It tends to go much faster. Excellent.
Might want to get rid of some of those.
Yeah, let's get rid really quickly, let's just do that one last cleanup thing, which is on pointer press, we'll say if there are no points, then clear out the list. So if touchmap.count equals 0, then just canvas1.children.clear. So again, this is one of those things as you build apps and think about touch, you want to think about the fact that you have multiple inputs, that these inputs are going to go on, that you need to deal with when are things manipulation and when are things contact, when you want to draw with them, etc. Great. Awesome. That demo worked. Fabulous. Thank you. So far we've done kind of a nuts and bolts buildup of XAML. We've talked about the architecture, we've talked about some of the changes that we've seen since the XAML that you all last saw, and walked through some of the important parts of dealing with the new input system.
But they're probably all parts that you've seen before, if you've been to the other XAML talks. So this is the really interesting part.
This is the interesting part. So Windows 8 is more than just new ways of putting pixels on the screen. Really, there's a set of personality that kind of typifies Windows 8 apps. And when you build things, I really think about these kind of three main things to do. One of which is plug into the personality, make your app look and feel like the rest of Windows. And that's not to mean clone the UI, but rather to follow kind of the aesthetic of the system. Plug into the contracts, which is really this way to have apps cooperate together. And Josh Williams has a great way of saying it, which is that contracts allow it that as you add more apps to the system gets better. There are more things to search on, there's more things to share with, there's more things to, play to. So the contracts are really the place that you can add a lot of value to the end-to-end system. And then finally, we all want to get paid. And so for this, you want to integrate with the store. And plugging into the store and being able to have ways of monetizing your apps is really one of the big value propositions of Windows 8. And so you're going to want to plug into all of these. So let's go through and show how you can use all of these features in your app. So we're going to start, switch our monitors. So we're going to start with a blank app. And the first thing we want to do is probably the most prevalent Windows UX experience in Windows 8 is the list view, is that grid view, that island of tiles that you can go and use, or a sea of tiles, I guess a better way. So we're going to add a grid view here to our XAML, give it a name. Exciting name, great. And then we're going to go put some data in it. So we have our grid view, and now we just need to put some data. So we're going to come in here to our main page, and let's create a data context and create a new observable collection. Just a list of data items with that fires change notification, so we can add and remove things to it over time. And then create a new object array, please. And we're just going to create some anonymous objects in C#. So we'll say name is Chris, or B, pick your favorite names. B, great. And we'll close this out. Close curly, close paren, semicolon, and then we have to import a type. Great, so that just allocated a couple items, threw them in the list, and now we're ready to go. In fact, we have one last thing to do.
Yes, we do.
We need to go to the grid view and put the data in there. So we put the data in our data context, and we need to do a binding statement. So this is the same binding you know and love. Say binding equals curly brace item source
yes.
equals curly binding. I get ahead of myself. Binding, and the default binding statement gets the data context and bind to it, which happens to be our collection. So we're good to go. So we have our list view. Awesome. So that's ugly in lots of ways. So first thing we need to do is let's create a template for our items so that they look a little better. So templates in XAML you can do by either creating a named resource and having them shared across multiple items, or in this case we're just going to create a template right in line. So we're going to say item template, we're going to create an angle bracket data template, and we'll put inside of here, how about just a
text block?
Text block, great. I was going to say div, but that probably won't work. And we'll bind the text property to be the name. Binding to name. And how about a width and a height on that too? Like 150 pixels by 100 pixels, or your choice. And can you put a background on it too? Just so we can see them as they go? Like maybe dark gray or something.
Really? Want this one?
Hot pink again.
Oh, that's not happening. Okay.
Oh, let's not put that there then. Great. We're going to pretend that that's there. F5. Awesome. So here we see a lot of the things. Can you touch swipe on one of those things? So we see we get a lot of that behavior that you expect in Windows out of the box. The styling is there, the selection model's there, touch input's there, keyboard will be there if we wanted it. All that stuff comes out for free. And so really by plugging into the grid view and styling it, you get a lot of that behavior out of the box. So text block is, grid view is probably the number one control. The number two thing that people like is the app bar. And this is that ability to edgy into your app and have commands come up from the bottom. This is so prevalent that in the XAML stack, we actually just added two properties to page, which is your bottom app bar and your top app bar, which are the two places that apps get to put their commands. So what we're going to do here is we're going to drop in a app bar, and we'll put a horizontal alignment stack panel, vertical, perfect, and we're going to put a command in here. So we're going to put a button. And what we're going to do is, this button, we're going to add items to our list. So we can put some folks in our list up the top. And so we're just going to say style equals. We need to style this to look like an app bar button. Conveniently, in the project here, we have some default styles. So the Visual Studio project ships with a file called standardstyles.xaml. And what we can do is we can go into that guy, and there's, 200 app bar buttons predefined in there. So we're going to look for the one we like, which was, I think, add app bar button.
Yeah, right there.
Great. We uncommented it, and so now it's available for us to use. And we'll go in, and we should be able to, can we run real quick and make sure that that actually worked? And so now if we edgy, we see it comes up, and we have our little add button. We need to wire up our event handler. Great. Click equals, awesome. And then go to the definition. And now we just want to add something to our list. So we said we put over the data context, we put this observable collection. So we're going to fetch out that data context. So dynamic d equals data context. This data context. We're just going to use the dynamic feature in C#, which lets us do kind of late typing to this. So we can say d.add. I just want to avoid watching lots of casts. And we'll say new open curly name equals. And we'll say, should we create, we created a robot army yesterday.
Robot army yesterday.
You want to create, instead of a robot army?
Aliens today.
Aliens today. So quote, aliens. You want to put a quote on that. And then just put d.count. Great. Now if we run, right click, we can create our aliens. Now you notice those fade in nicely. Add a whole bunch of them. Whale on that thing. I want the aliens to take over the world. And so now if we see, we can swipe now back and forth, and we're going to get panning. Those things are actually going to get virtualized into the content, and so all that stuff comes in there. Great. We have our alien army. They can take over. Great. Awesome. So that's step one, personality. Our app looks like a Windows 8 personality. Looks like a Windows 8 app. It behaves like it. Puts the commands in the right place. Uses the right type of styling for the grid. We're kind of good. The next thing we want to do is plug in to the contracts. Wow, I'm off today. So contracts, we talked about before, all those different charms bar. Can you bring out the charms bar? So the charms bar, we have these things like search, share, devices, etc. And what we want to do is we're going to plug into one of the easier ones, which is search. So if you click search today, you get this little search box. You can type into it. And then as you type into it, you can hit enter. You get the results for the things. You can see lots of apps can plug into it. The shell plugs into it. And so we want our app to be able to find all of our crazy alien army. And so what we're going to do is we're going to, first stop is we're going to go to the manifest. So that app, you'll notice that when we brought out that charms bar, there were a list of apps that already supported this. We didn't need to start up the app to go determine that it supported the search contract. It advertised it. And it does that through this technique called a manifest. That manifest allows you to say things like, what capabilities does your app need? So you can say, do I need to talk to the internet or not? Do I need to talk to the file system or not? It also says things like, what are the icons for the app? What are the port landscapes or the orientation that it supports? And what are the declarations, which is where you put all the contract stuff. So if we click down the drop down, we can see that, well, we click drop down.
Oh, I'm sorry.
Drop down, back up, thank you. There's a lot of these little contracts. Camera settings, plugins, you can create certificates, all kinds of crazy custom protocols you can go write. And so there really is quite a rich set of contracts you can plug into to really add value to the system. So we're going to do the search one. Add it. We're going to keep our app up and running, and so we don't need to worry about this right now. And then we're going to go to our C# file to write our handler for it. So great. So step one, we want to go listen. So the user types in, types. They press enter. We want to handle that enter key and do our search. So what we're going to do is we're going to go grab the windows.applicationmodel.search pane, which is the little pane doohickey, and we'll call my favorite API, which is get for current view. And on query submitted on the enter key, we'll go and write some code. Excellent. So we got our code, and instead of crashing, which I'm so glad that the C# thing, when it fills it in, just the default behavior for all methods is to crash. It's awesome. Fabulous. You're going to create this little variable. Oh, you started doing it. You were ahead of the game. Create an observable collection, because we want to take that data that we have in our list, and we actually want to mess with it a little bit, and so we're going to cache away the data here. So we'll say all data, so now we have a pointer to it. And then in query submitted, what we're going to do is we're going to swap out our data context. We're going to filter the data out and put it in our list. And so what we'll do is we'll grab that and say this.data context. We'll do a little fun link here. We'll say from dynamic item in this.alldata, where, and we'll say great item.name .contains args.queryText. That's the text that the user typed in, and I'll say select item. Awesome. That's enough, right?
I think so.
F5. Let's add some robots. Okay, we've got some aliens. Let's search for anybody named Bead. See, that goes away, and now if we search for all the aliens, sweet. So you see, with a couple clicks, a couple bit of code, we're able to plug into that search contract. We show up in the list. We're conveniently named app3, which is what everybody's going to search for this for. And I believe we now have enough value in this app to publish at the store and make money. So let's go and do that. Because this app is going to be so valued, we want to create a trial mode. I mean, really, the store has this amazing amount of commerce options you can go do. You can create trial modes. You can create expiring modes. You can go and have in-app purchases. You can have straight for purchase apps. You can have ad-funded apps. There's a ton of options you can go do for how you want to build this. By far, the one that I find most appealing myself as a human using my system is that I love the trial mode for apps. I love the ability to go in and download it, try it out for free, and then plug in and pay later. So what we're going to do is we're going to make this app support trial mode. So what Bede's doing is he's adding the first and most important button to add to your app, which is the Pay Me button. So what he's going to do is he's going to create a button that is in his app bar. That's going to be the Shop app bar button. And this is going to be the button that the user is going to click to pay us because they're going to be so eager to do so. He's going to go and grab the style, uncomment it. There's a big long list of these. There's an enum, and there are websites that show you what all of the different buttons look like, so you can go find those and browse them visually if you want. We're going to add that, and we're going to go to our button click. Great. So now we have to write the code to pay, because we're starting with the payment.
I think we need some code in here first.
There is. Wait, no, let's just, we have to stop a second.
Okay.
We've got to let them keep up with us.
Oh, right.
You know what you're typing. They don't know what you're typing yet.
You haven't done this before? Oh.
So the store has all these great options about how you can purchase things, but the one thing you want to be able to do is, of course, actually write the code against those things. You want to be able to test that. So there are two APIs in the system. One called Current App, which is the store's presentation and when you actually run your app for real on a customer's machine. And the other is called Store App Simulator, which is a fake, phony store which allows the user to choose what answers the store should give you. So you do not want to ship with the simulator enabled, and we will show you why in a moment. So what we're going to do is so that we don't have to have lots of ORs in our code throughout, we're going to have one place. We're going to put a using statement here at the top against appmodel.store.currentAppSimulator, because we're debugging, we're testing, and so it's okay for us to use this. So we're going to put a semicolon. So now we have that current app, and we're working a little bit backwards here. We want to do the payment first, so we're going to go to our button click handler, and we're going to say current app dot request purchased async. Perfect. And this gives one argument, which is whether or not you want a receipt. And so now the user can pay us.
Time to get paid.
Sweet.
That's why we're here.
However, we've given them no motivation. They just have to pay out of the goodness of their heart. So as with all trial apps, I want to make this app annoying until they pay us. So what I'd like to do is, can you write, let's add an event handler for current app dot license information dot license changed plus equals create a new event handler. So what this is going to be is every time license changes, so the user buys something, we're going to call this method when we start up as well. And what this is going to do is this is where we're going to update our UI to nag our user and make them annoyed so much that they want to pay us. So what we'll do here is we'll say if we have a license, so if it's active, which corresponds to it's a rate. It's a property, not a method. Great. And if it's not trial mode, so basically we have a good license, and it's not a trial license, then we're going to just set the grid background to be black. Which is to say, if it was something before, we'll change it back. So grid of content dot background equals new solid color brush of black. Great. So that's our non-naggy version, where we have a nice reasonable color. You'll need to import grid view. Sorry. Oh no, grid. You're right.
It's just slow. It's catching up.
And then in return, after we set it to black, and then what we'll do is if they haven't paid us, or if we have an invalid license, copy that line of code, and we will make it be a exciting color, yellow. Great. And now run. So we see we have not paid. Our app is very annoying. In fact, if you try to add some more things, you'll see that they show up, but we've picked such an awesome set of colors that the user is very compelled to pay us. So let's go and right-click, bring up the app bar, and pay us. This is why you don't ship with the simulator enabled. The user gets to choose what the store says. And so right-click, let's pay. No, make it succeed. Pretend that we gave them credit card. There we go. So here we have our app. We've now plugged into the shopping. So we've seen kind of all the major pieces here. We've seen the ability to go plug into the personality of Windows 8. We've seen the ability to plug into the contracts in Windows 8 and the ability to kind of leverage the store to actually monetize our app. Great. So we have one more thing we want to show, which is a truly unique part about XAML. So we talked before about how XAML has kind of this bottomless extensibility. You can plug in new controls, you can create new vocabulary to put into XAML, and you can write that in any language. The other thing that XAML has that is incredibly powerful is the ability to natively integrate DirectX into your XAML. So there are kind of two main ways of doing this. One of which is creating an image source, basically creating a custom image tag that plugs into your DX content. And so there are two options here, the surface image source and the virtual surface image source, which allow you to either do kind of a static image or one that as you pan, you dynamically add something. So you can think of this as, those will let you do things like the Bing Map style app with an infinitely scrollable surface that you're just dynamically creating this content for, but it's all in the hardware, so at the DX level. The other option is, for DX fans in the audience, is this thing called swap chain background panel. And this is the ability to take an arbitrary DX swap chain and plug it into the background of your XAML app. So this lets you write like a game in full DX, full power, native code, plugged in, and then you can write all your custom controls in Chrome in XAML, which really gives you this ability to create a super high fidelity experience. So we just want to do a quick kind of little shot at this and show you what that looks like. So can you pop over and run this app? So great. So this is a similar app to the one that we just saw with the painting thing, except we're now rendering all of this stuff through DirectX. So as we touch, we're handling an event in XAML and then informing our DX app underneath the covers about all of these things. So in this case, we're using, I think you're using Direct2D to do rasterization of a radial gradient, and it's kind of crazy stuff. So really quickly, can we pop over to that code?
Yeah, we sure can.
And I just want to show two kind of key points about this. First is, it's still XAML. We have a native DX surface being composed into our app, and it's all being done through very simple XAML markup. So we say a swap chain background panel, we're handling pointer moves, which we saw before. It's just simple events. And then the other thing is, now go back to the code where we wire up the panel. And here we see that other crazy stuff. So if you're DX gurus in the audience, which I expect everyone here programs in DX in their hobby time, right? Okay. We see a bunch of these, kind of crazy macro things, but what this boils down to is we query interface. Yes, you can QI in this world. That panel, the swap chain panel, that XAML element, we query interface for it from native code, grab an INO, and we set the swap chain panel here to point it to our DX swap chain. With this, it gives you unlimited control over what you can do in XAML. There is really no limit to what you can do here. And that's it.
Yeah, you can have your cake and eat it too.
So you can have all the ease of use. Great. Awesome. So with that, I would like to ask if there are any questions. Actually, no, I would like to wrap up first. Oh my goodness, this is horrible.
You want to get out of here, don't you?
I got to restart. Do you mind if I start over again and just do the talk again? So we've walked through kind of the end-to-end of XAML. We've looked at the basics of it, the fact that we've really rewritten the thing from the ground up to be a native platform integrated in Windows 8. We've given you unlimited headroom. You can both extend the control set as well as plugging in even native DX content right in the middle of it. It has all the familiarity you've seen in the phone and Silverlight, WPF, and you can really take those and just leverage those skills out of the box. The ability to plug into the personality, contracts, and store, very trivial code. The WinRT is directly exposed into your XAML apps, so you can really plug in there. There's a bunch of sessions on XAML today, so you can go look at performance tips of how to make this thing be super fast later today in this room with Kieran. Also, we have a bunch of stuff, a deep dive just on that list control. Just on the personality piece, we have a session on how to dive into that and really customize the list view to get the look and feel that you want. And then finally, under the theme of getting paid, there's a session on how to get analytics for your Windows Store app so you can really tune your app to try to make the most of it. So we really see is in Windows 8 there is this breadth of UI technologies you can choose from, XAML, HTML, and DX. And really with the XAML stack you get to use the thing that you've been familiar with and integrate in all the other pieces. Do you have any other?
I think that wraps it all up.
Great. Thank you very much. And if you have any questions, shout them out. Thank you. Any questions?
I've got a question.
Go.
So,
Yes.
in that example where you were doing the search contract,
Yes. It is. Yeah.
when it didn't return any results, is there some way you can just put in some feedback on that black blank space that says, sorry, no results found?
Absolutely. So the question was, if you have no search results, what would we have done in that app? We definitely would have showed an empty black rectangle. The other thing is you notice that there's, as you type, you can get immediate feedback below that. There's another event on the search pane which lets you return results over there, so you can actually return information in that as well. So you can plug in and do anything you want there. There's a question over here?
I noticed every time you close the app, you have to go and stop Visual Studio.
Yes.
Why is that?
I noticed every time you close the app, you have to hit the stop button. Why is that? That is because when you terminate the app by dragging it down, there's a brief delay as the process gets torn down. And when doing the demo, it turned into kind of, you always have this little bit of wait, and it's like a 1.5 second or 2 second wait, and then VS will go back to edit mode.
VS will
waiting for it to tear down.
time, yeah.
And so it makes it more reliable to hit stop. No other magic than that. Any other questions? Right here?
If we're not using the Windows Store, if we're just doing in-house stuff, where is that, or what do you do?
If we're not putting apps in the store, we're just doing in-house stuff, what do we do? So there is ability to sideload content, like if you're in an enterprise deployment situation. You can sideload apps onto the local machine. There's a talk on that, I think. If not, come grab me afterwards. I can get your information. But there's a story for how you can, in the enterprise, do deployments to Windows 8 machines. And if it's just for your friends, there's a developer key that you can install if it's just for you to test it internally.
Second, is there a render target bitmap?
Is there a render target bitmap?
There is not a render target bitmap in XAML right now.
Great. There was another question right behind you.
That was my question as well.
The render target bitmap?
On that, yeah.
Oh, great. That's awesome. Any other questions? So right here in the aisle.
Is there a reason why the XAML file is locked when you're debugging?
Is there a reason XAML file is locked while you're debugging? Because if you edit it, it will no longer correspond to the running app. We lock the files or F5.
You still have to compile those.
You still have to compile. Oh, you would prefer if we left it as read-write?
We're trying to do write code while we're looking at it and trying to do stuff.
That's a great question. I don't have a good answer on that. Sorry. I don't know other than that's how they did
I don't
it.
know. That's what Visual Studio does. Yeah.
Sorry. Another question? Oh, no, sorry. Any other questions out there? Wunderbar. Everybody knows everything. XAML apps for all. All right, thank you very much. Enjoy the rest of the conference.
Thank you.